In this video, we're going to go over how you can remember all of the high-yield cytokines for step 1. You can find these resources on First Aid pages 100 and 106. There's a full version of this chart on page 100, and the information here at the bottom will be from page 106. So first off, we have interferon gamma, which can be found here as activating the Th1 cell and also something that is secreted by the Th1 cell. It's also found in a couple other places, but this is going to be the part we're going to focus on the most. So first off, we see that interferon gamma is secreted by NK cells and T cells in response to antigen or IL-2 from macrophages. So here you want to remember that interferon gamma, as the inflexible general, is going to be born a natural killer, so it's secreted by those NK cells. It also really cares about being number one. As general, it's really important to him that he's always number one, so he's just going to focus on that Th1. So he promotes differentiation of CD4 cells into Th1 cells. And of course, for that reason, it's also going to inhibit Th2 and Th17. And then it's also going to continue and keep winning because even after it activates Th1, it wants to, the battle's not over till it's over. So it's going to continue to secrete interferon gamma here from Th1. And the next thing it does is also it induces the IgG isotype switching in B cells. So here I remember the IgG, the general is kind of full of himself, so he's going to want the B cells to secrete the Ig named after him. So it's going to be IgG for general. He's also going to command the soldiers to attack, so he's going to stimulate those macrophages to kill the phagocytosed pathogens. And he is really passionate, so you're going to see that even the villagers are going to join in the war effort. So here we see that he increases the MHC expression and antigen presentation by all cells, so not just the immune cells, but by all the cells, all the villagers as well. Next, we have IL-12, which is the egg soldier. So the egg should remind you of a dozen eggs, which is how eggs are often sold. And this will hopefully remind you that it ties back to IL-12. And it should also remind you that the shape of this egg should remind you that it facilitates granuloma formation in TB. And as a soldier, he works with the general, so he's going to help induce that differentiation of T cells into Th1 cells. And he's also close with the boss's family, the boss being the general, interferon gamma. And that means that he's going to activate the NK cells that the boss originally came from. For IL-2, we have these two recruiters. So specifically here, I've chosen to include pictures of the two recruiters from the show Johnny Test. And you'll recognize that the general is also from the same show. So hopefully, if you're familiar with the show, you can recognize that these characters all kind of work together. But the reason we bring them here is, if you're familiar with the show Johnny Test, you can remember that these characters are often involved in recruiting Johnny Test and his sisters in order to accomplish whatever mission is going on. So you can either imagine these two recruiters, or if you're not familiar with the show, you can imagine two army recruiters, for example. And hopefully this will help you solidify that the IL-2 goes along with interferon gamma. And also, what does the recruiter do? It's going to bring others into the battle, which is why we see that the function here is to the function of Th1 is to activate macrophages and cytotoxic T cells, which it accomplishes through both of these interferon gamma and IL-2. And here again, we see at the bottom that IL-2 stimulates the growth of helper, cytotoxic, and regulatory T cells and NK cells. For IL-4, I think the mnemonic provided by First Aid is pretty good, which is ain't too proud to beg for help. And the idea is that it induces differentiation of the Th2 cells, and it promotes the growth of B cells, and enhances class switching to IgE and IgG. But for our mnemonic purposes, I've just included a picture of a car here. A car has 4 wheels, hence IL-4, and you can see the car is kind of begging. So hopefully this 4-wheeled car begging will help you remind you of this mnemonic, which will then remind you that it's promoting the growth of B cells, enhancing class switching to IgE and IgG. For IL-5, again, here I think that the mnemonic is pretty good, which is I have 5 bays. So I've just included 5 bays in the form of the Spice Girls in order to kind of reinforce that. But the only thing you do want to pay attention to is that in the previous example, the B still stood for B cells. The two letters here both stood for the immunoglobulins, but here this is kind of different because here instead of standing for IgE, the E stands for eosinophils. So just remember that the 5-base mnemonic here, it's talking about the stimulation of growth and differentiation of eosinophils, not about class switching. So again, interleukin 5 promotes growth and differentiation of B cells, enhances class switching to IgA, and also growth and differentiation of eosinophils. For IL-6, we see that it causes fever and stimulates production of acute phase proteins. So acute phase proteins is talking about stuff like C-reactive protein. So essentially, the overall picture here is all about this kind of inflammation, this heat, fever, all that kind of stuff. And so I thought nothing was more fitting than a picture of Hades as IL-6. So how are you going to remember that 6 ties into Hades? You can think of the phrase being 6 feet under. So when you're 6 feet under, which is to say when you're buried and dead, then you're going to meet Hades, which is IL-6. So Hades, kind of god of the underworld, all this fire inflammation should remind you the effects of IL-6 causing fever and production of acute phase proteins. For IL-10, we have the 10 commandments, and the idea here is that IL-10 is known for attenuating the inflammatory response. So if this is something that kind of like tones things down, like makes you kind of like follow the rules, hopefully that kind of makes sense why that's connected to the idea of the 10 commandments. So it's going to decrease expression of MHC class 2 and Th1 cytokines, inhibits activation of macrophages and dendritic cells, and is also secreted by Treg cells. So I think the overall picture, rather than memorizing each of these details, is that it's kind of turning down the immune system. And again, we have the mnemonic here of both of these attenuating the immune system. So IL-10 attenuates. And just like the 10 commandments makes you follow the rules, IL-10 is kind of making the immune system follow the rules and kind of calm down a bit. Here we have a box of black cat tissues to represent IL-13. So we know that 13 is the number for bad luck, and black cats are also another symbol of bad luck. But why the tissues? So if you look down here, IL-13 promotes IgE production by B cells, and it also induces alternative macrophage activation. So with the IgE, that's going to remind you of how IgE is involved in allergic reactions. So if you have allergies, you're going to need a lot of tissues. But the other reason is because the tissues should remind you of tissue repair. Why? Because when it's talking about inducing alternative macrophage activation, it's talking about how IL-13 induces macrophages to adopt an M2 phenotype, which is essential for tissue repair and for resolving inflammation. It can also contribute to chronic disease, though, if it's not properly regulated. But the idea here is M2, this macrophage activation is associated with tissue repair. So we have tissues both to represent tissue repair and to represent the allergic reactions from IgE. Notice this candle shaped like a 1, which should remind you of IL-1, and it's a bone candle. So why bone? Because IL-1 is also called osteoclast activating factor. And why a candle? So there's 3 attributes of candles. They're sticky, they're smelly, and they're fiery. So fiery because it causes fever and acute inflammation. Sticky because they activate endothelium to express adhesion molecules, and they're smelly because they're inducing the chemokine secretion to recruit white blood cells. So if you remember those 3 characteristics of the candle, sticky, smelly, fiery, and you also remember this candle is bone-shaped, that should remind you of everything that's involved with IL-1. So IL-3, we think of the 3-headed dragon. One thing to know here about IL-3 is that it is secreted by T cells, but it's not listed here on this diagram because it's also secreted by other cells like mast cells and eosinophils, and its function has less to do directly with the immune system. So if you look at what IL-3 does, it supports the growth and differentiation of bone marrow stem cells. So the idea here is just like the dragon has this one body, but then it differentiates into 3 different heads, so too does IL-3 support the differentiation of the bone marrow cells. So again, this is just talking about the different kinds of cells it allows for differentiation into. So in terms of the individual function of certain cytokines, that's all you have to know, but there are some cytokines that you had to know kind of broadly what they do. So for example, we haven't talked about any of these 3 cytokines, IL-17, 21, and 22. But what we need to know is that they're secreted by Th17, so it's kind of nice. The numbers are either 17 or close to 17. And we need to know that it induces neutrophilic infiltration. So we can connect this back to IL-1, which we see here as an activator. So we can remember that the sticky candle IL-1, it activates the endothelium to express adhesion molecules. So if you know that IL-1 activates Th17, it should make sense why the downstream effects are neutrophilic infiltration, because as we know, those adhesion molecules are a big part of how neutrophilic infiltration works. And we can also use this concept to figure out what's secreted by a lot of these cells. So for example, when we look at the Th2 cells here, we see that it's associated with the IgE. And if we look at a lot of the interleukins that are secreted by it, we can see that they're very much associated with IgE in general. And the other group that we need to know is TGF beta and IL-35 down here with the Treg cell. So the idea here is if we know what IL-10 does, which we do, we know that it attenuates the immune system, we should be able to figure out that TGF beta and IL-35 kind of have those similar effects. So overall, it's going to prevent autoimmunity and maintain tolerance. So this isn't entirely true because, like, for example, TGF beta, we can see it's up here as an activator as well for Th17, which isn't involved in, preventing autoimmunity. But for our purposes in general, we can think of TGF beta as kind of preventing autoimmunity, kind of attenuating the immune system. So as a final point, we've talked mainly about how these cytokines relate to T cells, but we should know that they're also being secreted by macrophages. So we've talked about all of these cytokines individually, but we also need to know that these three first ones, they are part of the acute phase, and then these two last ones, they're part of the chronic phase. And also a mnemonic here straight from first aid that might be useful, but also leaves out a lot of the more key details is the hot T-bone steak. So IL-1 being fever for hot, IL-2 stimulating T cells, 3 for bone marrow, 4 for IgE, 5 for IgA, and acute phase protein for IL-6. And that does it for all of our cytokines.